Hello, I'm Andreas Polydorides from UCL's Interaction Center and Global Disability Innovation Hub. I will be demonstrating 3 different open-source methods of producing highly customizable wheelchair cushions using 3D printing. This is all in an attempt to enable a larger proportion of the wheelchair population to have access to personalized pressure relief. This can be done through pressure maps, or if that is not attainable, through a little creative work. We print our cushions with 40D TPU and 83A TPE, but as with most open source projects, we are sure once more people start printing their cushions, we'll see a wider diversity of materials and methods. The first method, which we quite unimaginatively call G-code generation, is fully comprised of Python code, currently using the open source full control library. This allows us to generate custom G-code, the commands 3D printers understand, to create lattices in the size of the desired cushion. By using a pressure map, we can customize its density at a localized level, so that the load is more evenly distributed. We created a simple web form, which you can access from your devices during the conference, so that you can generate your own cushion. It allows you to input parameters about your cushion, like its size and the kind of printer you will be using, and offers helpful tooltips if you're confused about any part of the process. The second and third approach follow the more traditional pathway to printing an object. We created a parametric model in 3D CAD software, which users can adjust to their needs, that is then imported into Slicer software. In the second approach, we slice the object into G-code with desired parameters. For example, the density of the cushion will be determined by the infill percentage, and its load distribution can be adjusted by picking a 3D lattice, like gyroid. If the cushion is larger than the printer, it can be divided up, with helpful connectors to join pieces back together. The personalization with this method comes from a post-processing Python script that adjusts the flow rate of each printing move based on your pressure map. The third and final approach is solely slicer dependent. Here, we alter all the necessary parameters, but before slicing, we use SVGs as modified geometry to alter the infill locally and mimic a pressure map. This method is great for users who may not have access to a pressure map for financial or geographical reasons. The G-code for many of these approaches can be viewed in a Slicer software before printing and then sent to the printer to come to life. We will be showcasing example cushions from each of these methods, allowing you to generate your own through the web tool or modifier methods, and see a cushion printing live. Thank you.